All right, here we are. State whether the function has an inverse. If the inverse of inverse of f exists, find a rule for the inverse of f of x, and prove that f of x and f inverse of x are inverses. So, if we think through this a right here, that is going to be a V-shaped graph, and that clearly does not pass the horizontal line test. So this one here does not have an inverse. So as V-shaped, no inverse. So now B over here says f of x equals 2x minus 4, and if we think of that, that's a line, a straight linear function. And so this one will have an inverse, and so let's go ahead and find out what it is. We've got to find the rule for it and then prove that it exists. So first off, think of this as y equals 2x minus 4. And so for the inverse, it's going to be x equals 2y minus 4, and we got to solve for y. So let's see, add 4 to each side, and so we've got x plus 4 equals 2y. I probably should go back and make sure my 4 is clearly a 4 here. 4. And then divide everything by 2, and we end up with 1 half x plus 2 equals y. So there's our inverse function. And so maybe to rewrite that more specifically, f inverse of x equals 1 half x plus 2. Okay, so we've written our rule now at this point. We've said what our inverse is going to be, and it's going to be f inverse of x equals 1 half x plus 2. And so now we've got to prove that. And so remember what we said at the very beginning of the notes, that if we have f of f inverse of x, that when we plug an x into the inverse and then plug that output as the input into f, we need to get back to our original input, which is x. Likewise, f inverse of f of x, same thing. When we plug something in for the for the function of f, and then plug that output into the inverse of f, we need to get out that same output. So let's go ahead and go through that now. All right, so first one being, here's our proof of it. So if we have f of f inverse of x, we get to practice our composite functions right now. So what is f? F was 2x minus 4. But instead of x, we're plugging in the inverse function here. So 2 times 1 half x plus 2. Multiply this all out, and 2 times 1 half x is just x. 2 times 2 is plus 4, and then at the end of it, minus 4. And 4 minus 4 is 0, so we end up with just x. So it works. It's going to be true. Now we've got to make sure that it works for the other one as well. So let's go with f inverse of f of x. And we're going to need to get x as our output here, or x back out again, as our output for f inverse. And so first off, this one here is going to be, what was it, f inverse? 1 half x plus 2. But again, x isn't what we're plugging in. We're plugging in the f function. So that was 2x, what was it, 2x minus 4. Minus 4. And so 1 half times 2x is going to be x. 1 half times negative 4 is negative 2. And then afterwards, plus 2. So we end up with x minus 2 plus 2, well, negative 2 plus 2 is 0, and so we end up with just x. And so this is also, we've now proved our function. We plugged in x into f of inverse of f of x. We got back out our original input, and then here, likewise, when we plugged in x into f inverse of f of x, we got, again, as our output, we got x. So these are inverses, and here's our proof of that. So hope that helped.